So thank you all for being here. My name is Sebastian Diaz. Let's advance a little here. So our idea today is present for all of you how in Qubika we built a financial agent using Databricks and LangGraph. So a little intro about me. I'm Sebastian Diaz. I'm the Senior Vice President of Data and AI on Qubika. I have more than 15 years of experience on IT. I was a programmer before, and 10 years of experience on the data side. So first of all, to start, and I always like to start with a good baseline before going deep dive on the technical side. So you know how different companies are advancing, and they are in different maturity side on the AI. So we see that machine learning, deep learning, Gen AI, Agentic AI is right now the step that everyone is fighting, everyone is trying to solve it. So our idea today is to present you a little how we are able to solve that, and especially what is most important to us, what were the things that we discovered in this process. Because there are a lot of gotcha moments that you are not able to see until you face it. So we were with a big challenge in our clients that they were looking to be faster, to be able to retrieve data faster, but also that data makes sense. So let's put a scenario. Let's say that we have a client that has 400 tables, 2 terabytes of unstructured data. And each time they want to take a decision, it takes for them 1 day. Why? Because they need to cross-reference all the information. And there was a client that were moving so much data and so much money that day that they lose to actually bring the information was money. So here when we start facing this and say, okay, how we are able to deal with this? So this is the solution that we were able to arrive. So what we say is, so we have our structured data, semi-structured data, unstructured data, and the context data. So for us to be able to build a solution, we would need to take in consideration all of this. Everything was needed to move to a data storage, and leveraging on Databricks and other technologies, we were able to build these agents on LangGraph to actually use it in different front ends, Slack, Teams, custom front end applications, and so on. So why we did this? So mainly because this information, these integration sources that you see here, they were really messy. They were separated in silos, and also they were not thinking about it to use in AI. Also, and I don't know if this happens in your companies, but it's really common, a lot of our clients, they don't have business knowledge. What this means is they expect AI to actually doing things about business, but they don't have actual business documentation on how this works. They don't have a document about the different key terms, the different teams, what it means, the business rules, and so on. So what you find is that they want to AI replace or automate process, but they don't give the info on how they're supposed to do it. So we find as a first challenge to get all this information, move it to a place that was useful, like for example, a cloud storage, and after that, we start guessing and getting all the information. The interesting thing here is that with Databricks, we were able to leverage on the tools to actually build a spectacular lake house structured database, and the business knowledge, we use a vector DB, a Milbus DB to be able to build it. And lastly, we implement Elasticsearch, but I'm going to leave that part to the end to explain why we did it. Lastly, the agentic side we implemented with LangGraph because it gave us the opportunity to constantly interchange the things that we didn't need to interchange. Because it's not about connecting an LLM and that's it. It's about how you're able to solve this AI solution. So this was our approach on combining LangGraph with Databricks. So let me put you some business context. When we start this project, our client asked us, I want to be able to query all the information. I want to have governance control to know who is access what. And I want 0 hallucinations. if everyone here work with Gen AI or you work with ChatGPT, you know that that's impossible. It's impossible to reach zero hallucinations. Why? Because generative AI models tends to hallucinate because it's a probabilistic approach and not a deterministic approach, and that's okay. So how was Qubika able, combining Databricks and LangGraph, able to sort that? So the first thing that we say to our client is, it's going to hallucinate. Obviously, they tell me like, wait, what are you telling to me? It's going to hallucinate. The thing is how you are able to deal with that hallucination, so you are able to give something that is 100% accurate. So what we did is we separated the problem in 3 parts. The first part was interpretation model. I'm not going to be able to answer what I'm supposed to answer if I don't understand what I'm supposed to give. Understanding the users is key. And I don't know if you know this, but the user don't know how to ask things. They don't know how to use sometimes natural language applications. They do some vaguely, they ask something really small, but they refer in so much context. So what we well needed to do was understanding what this user actually asked me. The second thing was retrieving the information. And the third one was validating to reduce the hallucination and reach an almost zero hallucination approach. So let's start this journey with these 3 models, and I want to tell you some of the things that we discover jumping from these models to others. So let's start with the interpretation model. So what were the assets when we start talking about an agent that is able to understand what the user wants? First of all, the actual question or the prompt that the user is giving me. The reality, it was pretty bad. People didn't give enough context to actually do it. The other input that we had was chat history. With those 2 things, we start processing. So first of all, with chat history, we summarize it. So we are able to summarize a complete conversation on something that the LLM is understanding what's supposed to be, what was the talking, and keep maintaining a conversation. The other side was rewriting the question. And how we were able to rewrite the question. So this is something really interesting. First of all, we take the question, the original question, we take it to an LLM, and we rewrite the question with a business knowledge. So for example, let's say that someone is asking me for, give me the full year revenue for 2024. So, okay, what is revenue? Where am I supposed to get the revenue? Where I supposed to get that information? So all that business knowledge, we build it with Unity Catalog, we build it with rules that was existing on the company, and also with our own interpretation to give to the AI. All that we take it, we retrieve the semantics, we identify the key terms, and we create a new question that was more depth than actually what the user asked. With all that, we are sending an answer, a question rewritten to the next output. You know something that we were needed to ask when we are in this module is, do we have the data? Is this something relevant for me? Or he's asking me about how to solve a Python problem. So this is something that in the module we try to understand. He's asking me a question about the company. He's asking me about a question that I'm supposed to see the accounting business knowledge or the HR accounting knowledge. So when we are able to understand who is asking the question, what he actually wants, and if I'm able to give that information, we go to the next module. As you see, for the chat history, we use Milbus, a vector DB. So we were able to get all the information, all the memory into a vector DB. So it was really useful to do it. This is something that is really difficult to manage because, you know, When you are summarizing a conversation, when you start summarizing, maybe when you summarize, you lose information. So how you handle the conversation, the previous conversation, is a challenge because you need to be performant enough so you are able to quickly give this information, but not so much performant that you lose information about the talk. What was important? Are we changing subjects? Are we still talking about the same? And when we start developing this on the start, we were having an issue that maybe any one of you had, that was after the 7-6 question, the chat started losing context. Why? Because it was too much summarized. And the last answers were not, they didn't have enough weight in comparison of the other part. The business context, this was key. Without business, we are not able to actually answer something about the business. My recommendation to all my clients, you know when 10, 15 years ago, everyone's saying, start storing your data, start getting a data platform and storing your data. My recommendation for our client is start storing your business knowledge. Doesn't matter that you don't know how to apply AI, doesn't matter that you don't have a business case, you need to start documenting your business knowledge. And right now with AI tools, it's easier than ever. Start getting your documents and save it in a place. Start processing, like the information needs to stop living in the mind of the people and needs to start being a place that AI is able to use it. Because it's something lamentable, but people leave the company and all their knowledge is lost forever. So we need to start saving the business knowledge. We need to have a clear list of key terms. Like maybe we are using, and I always joke about this, like you go to utilization. Utilization is a metric to identify how much your team is being utilized on a billable rate. But that way of calculating utilization that is in ChatGPT maybe is different in your company. Maybe in your company you take another thing, and maybe you call it in another way. So having a key term identifying module is really important. And also to augment the question, you need to understand what is the actual context to give a question more useful to the output. You know something that we learned when we were working here? Our first approach was putting an LLM to do all of this. We put GPT 4.0, and yeah, let's go, do it. You are really intelligent. What was the problem? It was hallucinating, it was too expensive, and takes so much time that when you are maintaining a chat, you were losing time processing on this. So we divide the problem and we think it, hey, how a human solve this? Okay, so a human in his brain, he has different parts that solve small parts, and they do a compounding of all of it to actually reach to the answer. And when we start doing that, we discover that LLM were not always the solution. So for example, to detecting if the question is relevant to the business, we use a BERT model. A BERT model is a model really small that you need to fine tune, but the results are amazing. It's really fast, really good. And we had better outcomes with a small BERT model only to detect the intention of the question than actually using an LLM for all of it. So my recommendation to detect intentions, don't try to solve it with one bullet. Divide your problem, solve it in different parts. And also this is going to give you the ability to, if tomorrow technology keeps growing, to remove parts of it and change it, update it, and so on. Build in modules. This is our recommendation for intention side. After that appears the retrieval model. So I have my augmented questions, I have my knowledge KTR, key term recognition input. So I get the abstract questions, I get my relevant query templates. So this is an example of queries that are relevant to the business. I have my catalog that we bring it from Unity from Unity Catalog of Databricks. And with all of that, we create the SQL query, and we use Databricks MCP to get the information that we needed. With the SQL query result, we go to the last module, the validation model. And look, this is really interesting. The validation model, their input is not only the SQL query result. Why? Because what happens if you get bad on the intention classifier? You are not going to note that the actual SQL result is bad from the start. So for the evaluation, we give the original question, the SQL query result, the business context, the SQL query originally, the Unity catalog, and the SQL query output CSV, that one, the query template. And with all of that, we built our evaluation platform in MLflow, that it was composed by 3 things. Built-in metrics, these are metrics that you already have in MLflow, or you're able to have a package like Lens to actually implement it. Custom LLM metrics that we develop. Here you can use an LLM judge to actually evaluate. Heuristics, these are hard rules on the business that you need to have in consideration to evaluate the answers. And the last one, and the most important, the human in the loop. Human in the loop is one of the most important evaluations on the evaluation platform. With the result of all that, we did a ranking that gives a probability of the answer that I'm going to give you, how confident it is. And maybe we have 3 different answers, and we have a confidentiality score. If the ranking is low, then we are going to back to the previous models and iterate this. If the ranking is high, then we take all that information, and now we give it to a strong LLM, a really intelligent LLM, like 4.1, and he's going to grade the last natural language answer. The amazing thing is that most of our other approaches, when we hear it and see it from our other company or other customers, what we see is that they try to solve everything with the most potent LLM. Here we almost do everything with a 3.5 GPT, and we always use the higher one at the end. Conclusions. To achieve high accuracy and minimize hallucinations, you need to combine and create a compound model with a strong observability. If not, what you are doing, it's like trying to gamble the answer. And when you are having people taking accountable solutions and decisions with this, you cannot gamble with this. It's important to note that things are going to hallucinate and build guardrails around it. Don't try to say, no, it's not going to hallucinate. It's going to do it. Okay, what you are going to do when that happens? And also, by building solutions in modules, you are able to observe them individually and also optimize the performance. So if tomorrow things change, you are able to plug and play it without re-engineering the solution. And believe me, in the AI world, things are changing weekly. So you need to be flexible enough to build this. Lastly, it's important to have a strong data foundation. This client, when we start working, they didn't have Databricks, and having a strong data foundation was key for them. How you are able to actually build an AI solution if your data is divided in multiple places, not well structured, bad quality. So having a strong data foundation is the key for any AI projects. The last thing, I want to add a lot of technical things that I would love to share with you. I'm not able to do it in this time, so I'm going to invite you to our booth, in Qubika booth, that is near the Theater 4. One amazing thing is that there are so many things that we start doing with graph DBs in this solution, and memory, and governance, and so I would love to tell all of you. So yeah, thank you so much for your time. I hope that this helps you showing our experience and the things that we deal working with LangGraph and Databricks. And thank you so much.